Imagine you are hosting a giant cookout. You live in a neighborhood with billions and billions of houses, stretching as far as you can see in every direction. Your neighborhood has been around for a very long time, giving everyone plenty of opportunity to get settled and maybe even get a little bored. So you decide to send out invitations. You send out millions, no, billions of them. You announce your party on every channel with bright lights and loud music, hoping to attract some guests. You wait, you listen, but nobody shows up. The silence is deafening. You start to wonder, is anybody even out there? Or did they all decide to stay home? This simple idea is a lot like the situation we find ourselves in on planet Earth. We live in a vast cosmic neighborhood called the Milky Way galaxy, which itself is just one of billions of galaxies in the observable universe. We have started to send out our own kinds of invitations into space, radio waves from our televisions, our radios, and our scientific instruments. These signals have been traveling outwards for decades, carrying news of our existence. We are also listening, using giant radio telescopes pointed at the heavens, straining to hear even the faintest whisper from another world. We're ready for the party to start, but so far, the cosmos has been completely silent. The expectation that someone, somewhere, should have answered our call by now is not just wishful thinking. It's based on simple numbers and probabilities. Our sun is just one ordinary star among hundreds of billions in our galaxy alone. Many of these stars are much older than our own, giving potential life on their orbiting planets a head start of millions or even billions of years. If life is not a one-time miracle unique to Earth, then it should have sprung up in countless other places. Some of that life might have evolved intelligence, just as we did, and built its own civilizations, creating its own cosmic cookouts. So the question that echoes through the halls of science is a profound one. Where is everybody? This isn't just a casual curiosity. It's a deep puzzle that challenges our understanding of life, intelligence, and our own place in the cosmos. The silence from the stars is one of the greatest mysteries of our time. It's a mystery that makes us look up at the night sky and wonder if we are truly alone in this immense, dark expanse. The search for an answer takes us on a journey through the biggest ideas in science, from the birth of stars to the very nature of life itself. The puzzle of the silent universe has a name, the Fermi paradox. It is named after the brilliant physicist Enrico Fermi, who, during a casual lunch conversation with his colleagues in 1950, asked a very simple yet powerful question. While discussing the high probability of extraterrestrial life, he suddenly blurted out, "But where is everybody?" This question cut right to the heart of the matter. If the universe is so vast and so old, and if there are so many potential places for life to arise, then we should have seen some evidence of it by now. The paradox lies in the stark contradiction between the high expectation of alien life and the complete lack of any proof. Let's break it down into even simpler terms. On one hand, you have the argument for aliens. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. That's a staggering number. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. Many of these stars are similar to our sun and likely have planets orbiting them. Some of those planets are probably in the Goldilocks zone, where conditions are just right for liquid water to exist, not too hot, not too cold. Given these numbers, it seems almost mathematically impossible for Earth to be the only planet with life. On the other hand, you have the unsettling reality. We have found nothing, absolutely zero. No alien radio signals, no giant spaceships zipping past our planet, no megastructures built around distant stars. We have been actively searching for decades with sophisticated technology, yet the cosmos remains stubbornly quiet. This is the great contradiction. The logic says the universe should be teeming with civilizations, bustling with activity like a busy city. But when we look and listen, all we perceive is a silent, empty wilderness. The Fermi paradox isn't about whether aliens exist. It's about why we haven't found them when all our calculations suggest we should have. This mystery forces us to confront some very big ideas. Does the silence mean our understanding of life is wrong? Or is our understanding of the universe itself incomplete? Perhaps our methods of searching are flawed, like trying to find whales by listening for bird songs. Or maybe there's a more unnerving reason for the silence, something that stops civilizations from ever reaching the point where they can announce their presence to the cosmos. Enrico Fermi's simple lunchtime question has since spiraled into one of the most debated topics in science, pushing us to explore every possibility, from the mundane to the truly mind-bending. To truly appreciate the strangeness of the Fermi paradox, you have to get a sense of cosmic scale. Let's start with the stars in our own backyard, the Milky Way galaxy. Imagine every star is a single grain of sand. If you were to collect all the stars in our galaxy, you would have enough sand to fill a large dump truck. Now remember, our galaxy is just one. If we represent every galaxy in the observable universe as a grain of sand, we would need enough sand to fill a giant football stadium to the brim. That's how many potential homes for life we are talking about. The sheer number of opportunities is almost beyond human comprehension. Now let's add the element of time. The universe is about 13.8 billion years old. Our solar system, by comparison, is a relative newcomer at just 4.5 billion years old. This means that there have been billions of years for other star systems to form, for planets to cool, and for life to potentially emerge and evolve. If a civilization arose on a planet orbiting a star that is, say, 6 billion years old, it would have a 1.5 billion year head start on us. Think about what humanity has accomplished in just a few thousand years of recorded history, or even in the last 100 years of technological advancement. What could a civilization accomplish with a billion-year head start? Such an ancient civilization would likely have technology far beyond our wildest dreams. They might have mastered interstellar travel, allowing them to colonize their entire galaxy. They might be able to harness the energy of their parent star, or even manipulate the fabric of space-time itself. We would expect such a powerful and widespread civilization to be noticeable. They would leave behind cosmic footprints, waste heat, engineered stars, radio chatter, or even physical probes exploring new worlds. The fact that we see none of these things is what makes the paradox so profound. It's like looking at a forest that has existed for millennia and finding no signs of animal life whatsoever. This combination of vast space and immense time is what fuels the paradox. The universe provides the ingredients for life in abundance. The chemical elements made in the hearts of stars, the countless planets, and the billions of years for the slow process of evolution to work its magic. Given this cosmic recipe, it seems that life should be a common outcome, not a rare accident. And if life is common, then intelligent life should have arisen multiple times. So, the silence we observe is not just a lack of evidence, it's a direct challenge to what we think we know about the cosmos and the emergence of life within it. To give the search for extraterrestrial intelligence a more scientific framework, the astronomer Frank Drake developed an equation in 1961. The Drake equation is not meant to give us a precise final answer, but rather to organize our thinking and identify the key factors involved in the search. It's like a recipe for estimating the number of detectable alien civilizations in our own Milky Way galaxy. The equation multiplies several variables together, each representing a piece of the puzzle. It helps us see just how many things have to go right for a talkative alien civilization to emerge and be found by us. The equation starts with the rate of star formation in our galaxy. Then, it asks what fraction of those stars have planets. Thanks to missions like the Kepler Space Telescope, we now know this number is very high. Planets are incredibly common. The next step is to estimate how many of those planets could actually support life, the ones in the Goldilocks zone. From there, the equation gets more speculative. It asks, on what fraction of those habitable planets does life actually arise? And on what fraction of those planets with life does intelligence evolve? These are huge unknowns, as we only have one example: Earth. After intelligence, the equation considers another crucial factor: technology. It asks what fraction of intelligent species develop technology that releases detectable signs of their existence into space, like radio signals. This is the step where a civilization becomes findable by our current methods. Finally, and perhaps most importantly, the equation includes a variable for the length of time such a civilization broadcasts those signals. This last term is the great filter of our time. A civilization could last for millions of years, but if it only uses radio technology for a century before moving on to something else, our window of opportunity to hear them is incredibly small. When you plug in optimistic numbers into the Drake equation, assuming that life and intelligence are fairly common outcomes, you can get estimates suggesting that there should be thousands or even millions of detectable civilizations in our galaxy right now. This is the mathematical heart of the Fermi paradox. The equation shows us that, based on what we think we know, the galaxy should be humming with signals. The fact that it isn't suggests that one or more of the terms in the equation must be extremely small. Either life is much rarer than we think, intelligence is a fluke, or advanced civilizations simply don't last very long. One of the simplest and, honestly, perhaps most humbling answers to the Fermi paradox is that we might be alone, or at least incredibly rare. This idea is known as the rare Earth hypothesis. It suggests that, while simple microbial life might be common throughout the universe, the evolution of complex, intelligent life like ours requires an exceptionally long and unlikely series of fortunate events. It's not just about being in the Goldilocks zone. Earth's circumstances might be so uniquely special that they are, well, almost impossible to replicate elsewhere. The cosmic lottery might have so many required winning numbers that we are the only ones to have hit the jackpot so far. Think about all the things that had to go just right for us to be here. We have a large moon that stabilizes our planet's axial tilt, giving us a relatively stable climate over long periods, which is crucial for the slow process of evolution. Without our moon, Earth would wobble chaotically, leading to extreme and unpredictable swings in temperature. We also have a giant neighbor, Jupiter, whose immense gravity acts as a cosmic bodyguard, deflecting many comets and asteroids that would have otherwise slammed into Earth, causing mass extinctions and resetting the evolutionary clock over and over again. Furthermore, our solar system is located in a safe and quiet part of the Milky Way, far from the chaotic and radiation-filled galactic center. Even our planet's geology plays a critical role. Plate tectonics, the movement of Earth's crustal plates, helps regulate our planet's temperature through the carbon cycle and creates the continental landmasses we live on. Without it, Earth might have become a barren water world, or a runaway greenhouse like Venus. The list of these lucky accidents goes on and on, from our planet's magnetic field that shields us from harmful solar radiation to the specific amount of water we have. So, the rare Earth hypothesis argues that the silence we observe is not a paradox at all, it's the expected outcome. The universe isn't empty. It's just that the step from simple life to a technologically advanced civilization is a nearly insurmountable hurdle. We haven't found aliens because, for all practical purposes, there are none to find, at least not in our cosmic neighborhood. This is, honestly, a sobering thought. It places a heavy responsibility on our shoulders. If we are the only thinking beings in this part of the cosmos, then the future of consciousness in our galaxy rests entirely with us. Another fascinating set of explanations for the Fermi paradox suggests that aliens are out there, but they are deliberately hiding from us or choosing not to make contact. One popular version of this idea is the zoo hypothesis. In this scenario, ancient and highly advanced alien civilizations know we exist, but they have decided to leave us alone, treating Earth like a nature preserve or a cosmic zoo. They observe us from a distance, studying our development without interfering. Just as we have a prime directive in science fiction not to interfere with less developed cultures, perhaps they have a similar ethical code on a galactic scale. This idea is, honestly, pretty compelling because it accounts for the silence without requiring us to be alone in the universe. An advanced civilization might understand that making contact with a young species like humanity could be catastrophic for us. It could disrupt our culture, religion, and scientific progress in unpredictable ways. Imagine for a moment the societal upheaval if a fleet of alien ships suddenly appeared in our skies. To prevent this chaos, they might have established a quarantine zone around our solar system, waiting for us to reach a certain level of technological or social maturity before they reveal themselves. We are simply the uncontacted tribe in the vast Amazon of the cosmos. A related but slightly different idea is that aliens are not just hiding, but that we are incapable of recognizing their signals. Their technology might be so advanced that their communications are indistinguishable from natural cosmic background noise to our primitive instruments. It's kind of like an ant colony living on the floor of a superhighway. The ants are aware of vibrations and chemicals, but they are fundamentally incapable of understanding the complex system of traffic, information, and purpose that surrounds them. The cars and the data flowing through fiber optic cables are completely beyond their comprehension. We might be in a similar situation, surrounded by alien communications that we can't even recognize as artificial. Finally, there's the more paranoid possibility, the dark forest hypothesis. This theory proposes that the universe is like a dark forest filled with silent hunters. Every civilization is a potential threat to every other civilization. The safest course of action is to remain as quiet as possible. Announcing your presence by broadcasting signals into space is a foolish and suicidal act, as it might attract a predator who will come to eliminate you before you become a threat to them. In this, honestly, pretty terrifying scenario, the silence of the cosmos is not a sign of absence, but a sign of fear. The smart civilizations are the ones that are hiding, and we are the naive newcomers shouting in the dark. What if the answer to the Fermi paradox is not that we are rare or that aliens are hiding, but simply that we are early to the party? This hypothesis suggests that we might be one of the very first, if not the first, intelligent civilizations to emerge in the entire universe. While the universe is 13.8 billion years old, the conditions necessary for complex life might have only recently become favorable on a galactic scale. The cosmic timeline might be much longer than we imagine, and we are just the first guests to arrive at a party that will last for trillions of years. Think about the early universe. For the first few billion years, it was a much more violent and chaotic place. Stars were forming and dying at a rapid rate, leading to frequent supernovae and gamma-ray bursts that would have sterilized any nearby planets. The universe was also poorer in heavy elements, the carbon, oxygen, and iron necessary for life as we know it, as these are forged inside stars and scattered into space when they die. It may have taken billions of years for the universe to calm down and for enough heavy elements to accumulate to make rocky planets like Earth and life like us possible. So, it could be that the window for life to begin is only just opening. The average star in the universe is a red dwarf, which is much smaller and longer-lived than our sun. These stars can burn for trillions of years, giving life an immense amount of time to evolve. Perhaps the great cosmic story of life has barely begun, and the vast majority of life will emerge in the distant future, long after our sun has burned out. From this perspective, our existence is not a paradox, but a preview of what is to come. We are the cosmic pioneers, the first children of a universe that is just beginning to awaken. This idea carries both a sense of privilege and a profound sense of loneliness. If we are first, it explains the silence perfectly. There is no one else to talk to yet. It also means that the future of intelligent life in the cosmos could depend on the choices we make today. We would be the ancestors of a future galactic civilization, carrying the torch of consciousness into a silent universe. This perspective transforms the Fermi paradox from a puzzle about the past into a question about our future and our responsibility to survive, explore, and perhaps one day, welcome the newcomers who will follow us. Another compelling possibility is that we simply don't know how to look or what to listen for. Our entire search for extraterrestrial intelligence, or SETI, has been based on our own limited experience and technology. We primarily search for radio waves because that's a technology we understand and use for long-distance communication. But assuming that an advanced alien civilization would also use radio waves is a bit like assuming that they would speak English or use email. It's a deeply human-centric assumption that might be completely wrong. An ancient civilization, millions of years ahead of us, may have long ago abandoned radio as an inefficient and primitive form of communication. They might be using technologies we can't even imagine, like modulated neutrino beams, gravitational waves, or even forms of communication that operate in extra dimensions of space-time. Trying to detect them with a radio telescope would be like trying to listen to a modern fiber optic data stream with a 19th century telegraph machine. The information is all around us, but we lack the fundamental knowledge and tools to decode it. The cosmic conversation might be happening all the time, but we are not tuned to the right channel. Furthermore, we might not even recognize the signs of an advanced civilization if we saw them. We tend to look for things that resemble our own technology, like city lights or industrial pollution. But a truly advanced civilization might be so efficient and integrated with nature that it leaves almost no detectable trace. They might have mastered clean energy, perfect recycling, and sustainable living on a planetary or even stellar scale. Their existence might look more like a natural phenomenon than an artificial one. A star that dims in a strange way might not be a natural variable star. It could be a sign of a Dyson sphere, a giant structure built to harness the star's energy. We are only just beginning to consider these technosignatures. This hypothesis is a humbling reminder of our own technological infancy. It suggests that the silence is not in the universe, but in our own understanding. The problem is not that aliens are absent, but that we are not yet clever enough to find them. This is actually a pretty optimistic view, because it means the discovery may still be ahead of us. As our science and technology advance, we may develop new ways of looking at the cosmos, new senses that will allow us to perceive what is currently invisible. The search for alien life is therefore not just a search for others, but also a journey of our own scientific and intellectual growth. The Fermi paradox is more than just a scientific puzzle. It's a mirror that reflects our biggest questions about ourselves. It forces us to confront our place in the universe, the nature of life, and the possible futures that await humanity. Every proposed solution to the paradox, from the rare Earth hypothesis to the zoo hypothesis, tells us something different about who we are and where we might be headed. The mystery is so powerful because its answer, whatever it may be, will be profound. It will reshape our understanding of our own existence in a fundamental way. If we are truly alone, as the rare Earth hypothesis suggests, it means that the flickering flame of consciousness on this small blue planet is precious beyond all measure. We would be the sole guardians of meaning in a vast, unthinking cosmos. This realization would place an immense responsibility on us to protect our world and ensure our long-term survival. The hopes and dreams of the universe, in a sense, would rest on our shoulders. Every human achievement in art, science, and compassion would be not just a human achievement, but a cosmic one, the only one of its kind in our galactic neighborhood. On the other hand, if the universe is full of life but we are simply too primitive to see it, it offers a different kind of hope and humility. It suggests that we are part of a much larger, older cosmic community. We are children in a universe full of adults, with an immense amount to learn and discover. This perspective encourages us to keep searching, to keep improving our science, and to keep an open mind. It gives us a goal to strive for, to one day become mature enough to join the Galactic Club. The silence in this case is not an ending, but an invitation to grow. Ultimately, the search for extraterrestrial intelligence is one of the noblest and most inspiring quests humanity has ever undertaken. It unites us as a species, encouraging us to look beyond our small world and our petty conflicts, and to see ourselves as citizens of the cosmos. Whether we find other civilizations or not, the act of searching enriches us. It drives scientific innovation, expands our imagination, and deepens our appreciation for the wonder of the universe and the miracle of our own existence. The great silence of the cosmos continues, but our